Good morning, and welcome to AU Middle East. I'm Lynelle Cameron, and I am excited to be here with all of you today to talk about what we at Autodesk see as the future of making things. And I'm here at Autodesk because I believe that it's people like you who design and make things who are going to play a pivotal role in shaping our future. So welcome. Buckle your seatbelt. This is going to be fun. Whether you're designing cities, high-rises, wastewater treatment plants, making cars or video games, you want to feel like your work makes a difference. And you want to feel like you have the tools that empower you to make amazing things. You're probably here to learn from and listen to people who are using technology in incredibly powerful ways to solve some of today's biggest challenges. So I want to start with one of these challenges, a challenge that wherever you work, wherever you live, whatever you do, you are going to be faced with it. By 2050, there will be 10 billion people living on this planet. That's 30% more than we have today. Now, half of those people will be living in the global middle class with expectations of cars and computers and condominiums and all the goods that we enjoy in this part of the world. This explosive growth will require twice as much energy to power these lifestyles. And we know that we need to find cleaner and better sources of energy. By 2050, 75% of these people will be living in or near cities, many of which don't have the infrastructure to support this number of people. And many of these people will be living in cities that have not yet been built yet. We'll need to build 5,000 buildings today and every day just to keep up. And with more of us on this planet, we will have fewer resources. So we'll need to rethink how buildings are designed and constructed. It requires us to ask, what kind of future do we want to create? And how will we design for a growing planet on this finite planet, a growing population on this finite planet? This is today's reality. How do we design and make more things for more people, but do it with less negative impact on the planet? This is the opportunity of better design, and better design is about sustainability. It's about designing a future that's more efficient and less wasteful, but also more inclusive and affordable for more people. A great example of sustainable design here, close to home, is the Dubai Museum of the Future. They've been using integrative design processes to address a number of sustainability standards, and we'll be hearing more about this project over the next few days. In fact, many of our customers around the world are starting to think like this. Royal BAM is a construction services company. They've manufactured this pavilion for ABN AMRO as the new entryway to the headquarters in Amsterdam. It's built with materials that can be repurposed and reused instead of being discarded. The inner doors, the walls, the cables, the fire hose reels have all been reused from other construction projects. In fact, they have recycled blue jeans from the employees that's used in the ceiling insulation. And some of these components in the building will be reused and have a second life after the pavilion is dismantled. They call this circular construction, and it's a great example of companies who are truly innovating. Royal BAM is onto something. In just a few years, There will be an estimated $5.5 trillion market opportunity in low-carbon or circular goods and services. This is the future of making things. So now let's look at some technology disruptions that can help us create this future. We're seeing three major disruptions for technology catalysts for disruption: production, connection, and augmentation. We think you can learn from these, but more importantly, you can harness the power of these technologies to help design us into a better world. So let's dive in. So first, production. New tools and techniques like additive manufacturing, AR and VR technology are all combining to change the way we design and make things. Such as airplanes. Boeing will soon start using 3D printed titanium parts in the construction of their 787 Dreamliner jet. These are the first 3D printed structural components to be approved by the Federal Aviation Authority, and it will save $3 million per plane. Intellectual production has already changed. We design things through global distributed teams, and ultimately, AR and VR will change how these teams understand, predict, and make better informed outcomes of everything that they're designing. And our prediction is that as designed will become as built with a push of a button. You'll push a button on your design and it will show up somewhere. Machine algorithms will automate the process, spanning design, engineering, and fabrication. Design and production processes will inherently become more sustainable, avoiding waste from iterative prototyping, and lead to more efficient manufacturing processes that reduce energy from machine idling and production bottlenecks. A factory will receive a digital stream of instructions. But it won't just happen in the factory. It'll happen on the job site too. Check out this bricklaying robot from Construction Robots that helps augment the process and the masons building this brick wall. It places concrete blocks with precision, especially after a full day of lifting. It helps the workers safely and carefully build the wall. The second major catalyst is connection. All the things that you, our customers, make, whether it's a building, a movie, a car, or a highway, are now deeply connected to each other. The bottom line, things don't function in isolation anymore. They're smart. They talk to each other. They affect each other. They generate data and insights and change over time. Finally, we have augmentation. Technology today enables us to augment our human capabilities, amplifying our ability to solve complex design challenges, helping us co-create a future that we want to live in. Machine learning, AI, robotics, they're not only changing how we work, but they're also changing what we are now able to make. The good news is that we now have the technology we need more than ever to address the magnitude and the complexity of the design challenges that we face. Collaborating and partnering with machines in new ways is allowing us to create smarter and better products and better buildings. This is important because we humans can't actually solve the complexity of today's challenges fast enough on our own, and we need help. So these are the three major technology catalysts for disruption: production, connection, and augmentation. But before you start worrying about what this might mean for your business, let's take a look at some of the ways that companies are rolling with these changes and getting stronger as a result. In addition to building resiliency for these disruptions and implementing new technologies, they're also looking in different places for inspiration and ideas. Where? To entirely new places. And this is where we're seeing convergence. We're seeing convergence of how things are designed and made across industries. It's something that you're going to have to navigate in the future of making things. As the link between design and making gets closer and closer through advanced digital fabrication methods and the connected nature of places and things, you'll need to be able to adapt more quickly. And you'll be able to do so with AI and machine learning. So now let's take a look at a few of the companies who started this journey and are well on their way to designing the future. The Vama 12 plant in Norway, which is the country's largest hydropower station, has set a new standard for how infrastructure and construction projects. When it came time to modernize the century-old plant, the consultancy firm NorConsole sought to fully integrate BIM from conceptual design all the way to construction. Throughout the entire project, they challenged old ways of thinking and pushed the limits of technology. NorConsole used computational design to adjust and place the steel reinforcement in complex concrete parts of the structure, such as this turbine that you see here. Beyond the design process, the team used drones and reality capture to merge the new hydropower plant with the existing structures. On the actual construction site, the team interacted with BIM models on tablets for quality assurance to spot problems early in the design process. NorConsole used ever-improving technology to dramatically change how the power plants of tomorrow will be built. So let's look at an entirely different example from the manufacturing sector. The team at the Port of Rotterdam's Additive Manufacturing Field Lab, called RAM Lab, is pioneering additive manufacturing in the maritime industry. Now, currently, if a vessel comes into port and it needs a replacement part, for example, this, it needs a part like a propeller, it could take weeks or months to order and deliver that part, costing companies millions of dollars as they wait. But RAM Lab's vision is to create on-site, on-demand replacement parts and get these ships back on the water as fast as possible at the lowest cost. Pairing Autodesk's 3D modeling, optimization, and CAM tools with a hybrid manufacturing process, RAM Lab has created the first 3D printed large ship component without sacrificing precision or performance. But this is just the beginning. RAM Lab intends to use this approach to influence other industries like oil and gas, transportation, and space exploration. With the potential to save hundreds of millions of dollars a year, RAM Lab is setting the precedent for other industries to implement point-of-demand part production. The company is driving real innovation in the maritime industry. The emergence of the cloud is changing not only what NorConsole, RAM Lab, and Royal BAM are designing, but they're changing the process and how design is done. Previously, tasks like computational design, simulation, design optimization, and additive manufacturing were expensive, technologically challenging, and possible only for a few. But now, With the power of the cloud, these advanced technologies are available to everyone. And at Autodesk, we're embracing the cloud and are creating a new ecosystem so you too can be successful in this new world of making things. But what comes next? We believe that the next wave of innovation will be driven by data. Data as a technology platform. As sensors spread across every industry, the Internet of Things is going to trigger a massive influx of data. But data on its own is fairly worthless. It's only with infinite compute power and the cloud that data can now augment human potential. Data drives capabilities in artificial intelligence and generative design that were not possible before. So let me now show you what I mean with these 3 technology trends that are augmenting human capability. Generative design. We've been talking about generative design for a couple of years. With generative design, you're no longer simulating based on a particular design. Instead, you're simulating to discover a design. With generative design, you describe the intent, the goals, the constraints, the forces at play, and the tool uses abundant compute power to analyze the entire solution set to help you discover an optimal solution. Discovering designs that we humans would never be able to come up with ourselves. This chair's form embodies the evolutionary algorithm of generative design. But generative design is about more than synthesizing geometries. It's starting to understand something infinitely more complex, like the needs of people. Our team at Toronto has moved into a new building, and we're using that building as a living experiment. An experiment to discover how we could maximize employee productivity, well-being, and happiness. And to do this, we also used generative design. In addition to feeding the computer the forces impacting the building structure, we also fed it the factors influencing human productivity. We surveyed our employees, asked them questions. Who do you meet with? How often do you like to get coffee? How impacted are you by daylight or acoustics? The system then evaluated that survey data against a set of hard constraints, the boundaries of the building, the fixed kitchens, and so forth. And then it generated thousands of alternative floor plans with the intention to optimize for all the factors that are important to the employees living in this building, working in this building. And we weren't just pushing cubicles around like Lego blocks, and we weren't just stuck with the first floor plan that worked. And the result is an incredible work environment that maximizes human productivity and well-being, a building that incorporates real input from real people. So let's now shift to another exciting technology that is augmenting human potential, robotic systems. The physical capabilities of robots hasn't changed much in decades, but how we work with the robots is changing. I'd like to introduce you to our robot named Ash. Now, Ash is no different from other robots, except that we don't keep her locked in a cell. We've been working with Ash to teach her and give her freedom to 3D print in metal all by herself. Now, Ash doesn't rely on us for direction. Instead, she works as part of a closed-loop system and can self-correct as she prints. She produces almost no waste. She only makes what she needs, and she does it quickly and efficiently without polluting her surroundings. As we build more flexibility into the capabilities of Ash, we also need to build more flexibility into the way that we work with her. By bringing Ash into a full-scale, real-time VR environment, we can step into her world and have a closer relationship with her. We can interact with her intuitively and use our arms to manipulate her arms. This means that the space she occupies no longer has to be so rigid, thanks to VR. And by giving our robots new capabilities, the way robots work with us can become more fluid, augmenting and amplifying our human potential. The third technology trend I want to talk to you about that is augmenting humans is machine learning. Now, data is increasingly driving our design decisions, and as we capture increasing amounts of data, our traditional tools haven't been able to capitalize on this vast amount of data. But today, our tools can utilize massive quantities of data because of two things: the capability of machine learning techniques and the massive parallelism of the computing systems that they run on. Take, for example, the automated future of transportation. Now, self-driving cars aren't built on if-then statements, they're built on insights. They don't run on formulas and functions. Instead, they're predictive, projective, and productive. Machine learning focuses on the principle of driving, not the formula. If-then statements are like looking in the rear view mirror. But automated systems, they need to look forward and out into the world and learn from what they see, enabling them to sense the environment and respond accordingly. And they're not just responding, they're learning. And when one system learns, every other car learns, enabling enhanced capabilities to adopt and be adopted at an ever-increasing rate. But it's not just on the road where AI can help identify risks and obstacles. It's also happening on the job site. An artificial intelligence system from Smart.io is being used to keep workers safe. Smart.io uses still and video imagery to flag when workers are not wearing hard hats, safety vests, or other safety equipment. If a car can learn while driving, why can't a machine learn something like Maya's simulation tools the same way? What if we took a similar approach and used machine learning to cut through the complexity of something as challenging to master as Maya fluids? If Maya itself could use these settings, all of these settings, perhaps by manipulating each slider, dial, and drop-down, and correlate these to the resulting image, then it could do what visual effects artists do all the time. It could look at the reference photography and from this, use its intuition to infer the settings needed to create the effect digitally. So now let's move from visual effects to how we're making MoldFlow a more insightful simulation tool. And this gets at the idea of convergence that I was talking about earlier. Let me explain. The 10,000 materials in the MoldFlow database represent 30 years of data collection, all acquired from slow physical testing. And yet 2/3 of those materials still don't have complete properties. Through physical testing, we'll never finish this task. but machine learning can help us scale. We can take the materials we do know and use them to predict the materials that we don't yet know. We humans can't characterize across 10,000 items, but a neural network can. We're using such a network to extrapolate the data and complete the library for all 10,000 materials. And because this happens in the computer, on computer time rather than human time, we won't have to wait years for that data to be complete. So what if we could use machine learning to create a design tool of the future, an AI imbued with the qualities of a true design partner, a partner who's not just good at execution, but also at exploration? What might that look like? I'd want a partner who could bring a wealth of experience to the job, who would be curious enough to explore many different solutions to problems that I would ever be able to do alone. Someone who would stay up late tinkering around with the design, and someone who would continue to learn and grow on the project as we work together. Those are characteristics we expect from people, right? Shouldn't we also expect them from the computers that we work with? Imagine an Amazon Echo for design and make. Autodesk, open Project Toronto.
Loading project. Last night, the surveyor updated the laser scans. I have converted the scans to a 3D model.
Give me the plan view of the second floor and start the space planning mode.
Okay, here is the floor plan. Space planning tool initialized.
Add the views to outside module.
Okay.
Okay, Autodesk, import the program and employee preference spreadsheet.
Okay. Program and survey imported.
Now launch the study and provide me with 1,000 different design options.
Okay. Starting the adjacency preference, work style preference, buzz, productivity, and view analysis. Estimated time, 6 seconds. Studies completed. Running the daylight analysis. Estimated time, 3 hours. Would you like to see a predictive model that is 98% accurate? Estimated time of predictive model, 7 seconds.
Show me a preview of it.
Okay. Running the daylight predictive analysis. All studies completed.
Display all options in one view.
Okay. Here is a parallel coordinate plot representing 10,000 designs within the criteria range.
Show me 3 plot diagrams that map these options based on the design criteria.
Displaying plot diagrams.
Now show me the 10 designs that score highest in productivity, style preference, and lighting.
Okay, here are your requested design options.
Option 5 looks good. Let's go with this one. Send the proposal package to the client and the contractor.
Okay, a VR and 3D model as well as 2D documentation have been sent.
The vision is still pretty far off, but the power of the cloud, AI, and machine learning is bringing forth this future of making things. So here's what you can expect from Autodesk in this great future. You can expect us to be open, you can expect us to be innovative, you can expect us to continue to be a force for good. You can expect us to continue to use the Autodesk Foundation to invest in designers and engineers who are creating positive impact all around the world, like the UN High Commission for Refugees, who's working to design and construct settlements for 35 million refugees around the world. We'll continue to support people and organizations who are using technology for good. You can also expect us to continue to support and partner with organizations like Tech Women, a program that supports and connects women leaders from the Middle East, Africa, Central and South Asia to come and learn and share information with technology companies like Autodesk. You'll continue to see us and see our relentless innovation in the work our researchers are doing to advance design through robotics, generative design, and machine learning, all of which you'll hear more of throughout the next 2 days. And you'll experience it in our next generation of cloud-native products for manufacturing, AEC, and media and entertainment. With Fusion 360, BIM 360, and Shotgun, we're building single, integrated experiences that put your project, your building, or your movie in the center and allow you to move seamlessly from one context to the next. At the end of the day, we exist to do one thing, and that's to build software for people like you who are designing and making a better world. You can expect us to be open because we recognize that we absolutely can't deliver all the solution and every solution that everyone needs. That's why we developed Forge as an open platform for you to build on. At its core, it's a set of web microservices and infrastructure that provides an accessible, scalable, and predictable foundation that will power modern design, engineering, manufacturing, and construction applications. From modeling to simulation, visualization to collaboration, production to operations, Forge enables you to build modern, meaningful experiences that are right for your business. It's not just the things that you make that inspire us at Autodesk to keep pushing the boundaries and making our products indispensable to you. It's about giving you the very best technology to enable you to design and make a better future for all of us. This is what it means to realize the future of making things. And now that you have the power to make anything, what will you make? Thank you.